Welcome to The Explainer, created by Forge College. Okay, let's dive right in. Today, we're taking your Solana code, which right now is basically a brilliant but, slightly unpredictable lab experiment, and we're getting it ready for the real deal. Up until now, everything's been purely theoretical, right? You've mapped out those client interaction scripts, and you've designed the integration flows. But today we're putting on the lab coats. We're taking all those perfectly crafted assumptions and smashing them directly into the cold, hard reality of a runtime environment. It's time for guided deployment and test execution. Here is our agenda for this explainer. First, from blueprint to reality. Then, setting up the lab, deploying the prototype, asking, did it work, interpreting the diagnostics, and finally, next steps and debugging. Let's get to it. Section 1, from blueprints to reality, moving from the drafting table to the testing lab. So in our previous modules, you were basically playing the architect. You meticulously define the message formats, your account layouts, and all those RPC methods signatures. But today, you're the engineer actually bringing those blueprints to life. And the core philosophy here, and this is absolutely crucial, is that the goal right now is not to optimize performance. The goal is to expose mismatches. So please, take a deep breath and just let go of perfection for a minute. We literally do not care if the code is fast at this stage. We only care if your blueprint assumptions actually survive the strict reality of the Solana runtime. We've got to expose those gaps right now before we end up wasting hours on deep optimization later on. To put this into perspective, let's look at how this builds on what you've already done. Step 1 was your deployment plan, that checklist of accounts, key pairs, and environment choices. Step 2 was designing, creating those interface definitions, which is the literal contract your script has to satisfy. And now we're at step 3, testing. We're taking all the outputs from steps 1 and 2 and feeding them right into this practical execution phase. To pull this off, we need a testing vehicle. Enter the transaction demo. This is the exact artifact we're building today. Think of it like a specialized prototype machine. It's just a small, Rust-based client script, and its one and only purpose in life is to fire off sample transactions. It validates your RPC flows and signing behaviors against your on-chain program or your local validator. All right, moving to section 2, setting up the lab, preparing the testing environment. Before we start running this experiment, we need to gather our tools. You'll need your Rust toolchain, the Solana CLI, and your Anchor CLI. But crucially, you absolutely must place these specific artifacts into your Capstone project directory. We're talking about your main.rs file for your client entry point, your interface definitions, your deployment checklist, and of course your local key pair files. Basically, if these specific ingredients aren't in the mixing bowl, your client won't be able to read the interface definitions, and well, the experiment fails before it even gets off the ground. Now, you also have a choice about where to actually run this experiment. Think about the local validator versus devnet. The local validator offers this sweet, comforting safety of a completely deterministic, reproducible environment. DevNet, on the other hand, is a bit more of the Wild West. You've got to manage testnet SOL, and you must, I repeat, absolutely must, never reuse your mainnet key pairs there. So for our initial diagnostics, we highly recommend just sticking to the local test environment and making that your absolute ground truth. Which brings us to section 3, deploying the prototype. Time to flip the power switch. To flip that switch safely, we're going to meticulously follow our operational schematic. First up, running Solana Test Validator with the reset flag gives us a totally clean slate RPC node. Then, Anchor Build compiles your program binary. Next, Cargo Run executes the client itself. And finally, running Solana logs lets us stream the runtime output. If you run these in this exact order, you completely control the chaos. And right here, this is the magic invocation. This single command is the spark that brings your prototype to life. By passing in your deploy plan as the configuration, your client knows exactly which program ID and RPC endpoints it's supposed to use. You hit enter, and the machine just starts humming. Section 4, did it work? The what good looks like checkpoint. Okay, so the machine is humming, your terminal is scrolling with text, but we need to pause and actually verify if it produced the right artifacts without, completely melting down. Here's your success criteria checklist. Cross these off, and you're golden. We want to see a confirmed transaction signature generated, program logs that match your interface events, the expected state changes in your accounts, and of course, absolutely zero fatal errors. The whole point here is making sure your integration flows behave exactly like you specified in your design contract. Let me tell you, seeing this beautiful little string of text in your terminal, confirmed signature, is just the ultimate sigh of relief. It's verifiable, undeniable proof that your Rust client successfully talked to the Solana environment, signed a transaction, and the network actually accepted the whole shebang. Section 5. Interpreting the diagnostics. Reading the schematics of failure. Because, let's be real, sometimes experiments just blow up in your face. If you're suddenly staring at a massive wall of panic traces, don't panic yourself. There are a few usual suspects here. If you see signature verification failed, go check your key pair paths. If it says account not found, well, actually, that usually means you've got a mismatched program ID. It's a super common mistake. And if your confirmations are just timing out, double check that your local validator is actually running on port 8899. Look, I know the absolute dread of realizing you have a mismatched account order, but exposing these failures right now, that's a massive win. It's exactly what we wanted to happen. Let me just reiterate this one crucial principle. Make the local test environment your absolute ground truth. If your code works totally fine locally, but immediately fails on devnet, always prioritize reproducing and fixing that issue locally first. Doing that completely removes network latency and wonky RPC performance from your debugging equation. And the single best tool for uncovering that ground truth is this diagnostic command. By running Solana logs in a separate terminal window and piping it through grep using your specific program ID, you cut through all the noise. You can stream the exact runtime logs, watch your custom error codes pop up in real time, and match those timestamps directly back to your interface definitions. Section 6. Next steps and debugging. Moving to the debugging lab. So the dust is settled, we've gathered our baseline readings, and now you're basically building an evidence bag for your next task. You need to save a few specific artifacts. The exact terminal commands you ran, your transaction signatures, and hey, especially save the failing ones, along with your deployed program ID and your full client logs. This right here is your systematic debugging toolkit. It's going to be enough to trace and conquer almost every single error you run into when we transition into full-on debugging. All right, so you've successfully flipped the switch. Your prototype ran, it talked to the Solana network, and you've collected the data. But here's the million-dollar question. Sure, it ran, but did it run efficiently? Did it hit any invisible bottlenecks that are going to absolutely bankrupt you in compute fees once you hit mainnet? Well, we are going to uncover those exact answers next time in the debugging lab. For now, remember to head over to forge.college to learn more about this subject and explore an incredible range of other Web3 related topics from Forge College. Keep experimenting, and we'll see you in the next explainer.